In the early 2000s, the internet was a world of flat, 2D documents. But as hardware improved, there was a growing demand for immersive browser experiences, software that allows users to interact with depth and 3D space directly in a web page. The first major step toward that reality arrived in 2011 with WebGL. WebGL is a cross-platform API, or Application Programming Interface, that allows a browser to communicate directly with a computer's GPU. The GPU, or graphics processing unit, is the specialized hardware inside your device designed specifically to accelerate image rendering and 3D calculations. But WebGL was not designed for the average web developer. It is a low-level, verbose system. To draw a simple, unlit red triangle on a screen, you had to write hundreds of lines of complex matrix mathematics and manually manage memory buffers. This technical barrier created a massive bottleneck. Because the math was so stretching, 3D web development was largely restricted to specialized graphics engineers, keeping the technology out of reach for general web designers. In 2010, developer Ricardo Cabello, known online as Mr. Doob, released an open-source library called Three.js to bridge this gap. Three.js functions as an abstraction layer. In software, an abstraction layer is a tool that hides complex, low-level technical operations behind a simplified, human-readable command set. It allows a developer to write 5 lines of standard JavaScript, which the library translates for the GPU. That translation takes a flat 2D triangle and inflates it into a 3-dimensional cube with dynamic lighting and real-time shadows. This democratization of 3D meant that a browser could now function as a 3D rendering engine without requiring the developer to have a background in linear algebra or low-level graphics programming. To build these environments, Three.js uses a scene graph. A scene graph is a hierarchical tree of objects that defines the relationships and positions of everything in a 3D world. Every environment requires a few core components. First is the scene, which acts as the global container for all your objects. Second is the camera, a mathematical viewport that defines the user's perspective and dictates how 3D coordinates are projected onto a 2D screen. Once the scene is populated, you add the renderer. This is the engine responsible for taking the scene data and the camera's perspective and performing the actual drawing calls to the browser's canvas. Visible objects are built as a mesh. A mesh is created by snapping together a geometry, the structural mathematical skeleton, with a material, which defines the surface's visual appearance, such as color or texture. This structure changed the workflow for web developers. 3D development became a task of scene management and interaction design, allowing developers to move cameras and place lights by modifying simple properties in a script, rather than recalculating raw pixels. These building blocks scale up for professional e-commerce applications, such as the Gucci Virtual 25 sneakers. These use WebXR, an API that allows browsers to interface directly with augmented and virtual reality hardware to let users try on digital products. By adjusting material properties, developers can simulate photorealistic surfaces. The renderer calculates how light should react to matte canvas, glossy plastic, or reflective chrome in real time, matching the standards used in professional design tools. Google's Inside Music experiment shows how Three.js handles spatial data. It maps individual audio stems, the isolated tracks of a song, into a 3D coordinate system, allowing users to move through the music and hear different instruments based on their proximity. To manage projects of this complexity, many developers use React 3 Fiber, or R3F. It is a React-based renderer that allows 3D objects to be treated as modular, reusable components that participate in a standard web application's state and lifecycle. Treating 3D elements as standard components allowed teams to build complex scenes using the same workflows as traditional web apps. This integration ensured that 3D features were no longer isolated experiments, but maintainable parts of an enterprise software stack. Despite its versatility, WebGL has historical limits. When forced to process massive architectural models or datasets larger than 500 megabytes, the library's abstraction layer can introduce enough overhead to degrade performance. The transition to WebGPU, integrated into Three.js starting with revision 171, addresses this. WebGPU is a modern graphics API that provides more direct access to a device's GPU, offering better predictability and significantly higher performance for complex computations. Segments.ai uses this modern pipeline to render millions of LiDAR data points. LiDAR is a technology that uses laser pulses to create high-resolution 3D maps, which developers then navigate in real time to label data for training autonomous vehicle AI. At the sprawling physical venue for Expo 2025 in Osaka, Three.js was used to simulate 1 million individual particles in real time. The waves of connection installation displayed this simulation on a 98-inch 4K screen, controlled by the visitor's body movements. This move toward WebGPU has upgraded Three.js from a tool for interactive websites into an industrial-grade rendering engine. It is now capable of handling the same large-scale datasets and simulations once reserved for native desktop applications. The most recent shift in development is the rise of vibe coding. This refers to using AI agents to generate code based on natural language prompts, allowing developers to focus on high-level intent rather than manual syntax. A developer can provide a plain English prompt and have an entire scene, complete with geometries, materials, and lighting, populated by AI. This makes 3D scene creation accessible to a much broader range of creators. These AI-generated environments can then be experienced through WebXR. Using spatial headsets like the Meta Quest 3, users can step directly into the environments they've created without leaving their web browser. Three.js provided the web with a functional z-axis. By simplifying the connection to the GPU, it made the creation of spatial environments a standard feature of the open web, accessible to anyone with a browser.